Hi, I'm Pranaya and I'm here to present RLZero, which is a way to do direct policy inference from language without in-domain supervision. Say you get a robot delivered in a box. You want the robot to be able to do a wide variety of tasks without having to train the agent each time, and you would like to be able to specify tasks through an intuitive and natural interface such as language. Our work takes a step towards this motivation. We use unsupervised reinforcement learning and foundation models to enable zero-shot behavior from language prompt. So let's get started. Reinforcement learning concerns with decision making for reward maximization. To train RL agents to perform specific tasks typically requires reward design. For example, say you want to develop an RL agent for plasma control. This will usually require an expert engineer with domain knowledge to design a reward function that can capture the complexity of the task. This makes reward design inaccessible to people unfamiliar with domain knowledge. It can rapidly become infeasible when we want the agent to learn to perform several different tasks, and it has the risk of reward hacking. In addition, what we want are generalist agents. As more and more people interact with these agents, we want the agents to be able to perform a wide variety of tasks. This is where unsupervised RL comes in. It has a pre training phase and an inference phase. In the pre training phase, we take reward free transitions and we define a set of reward functions that are in the linear span of learned state features. This means our reward function is a dot product of features and a latent vector z. For each such z defining a reward function, we learn a z conditioned policy that optimizes the associated reward function. We call this z latent space as the skill space of the agent. At test time, we are able to find task embedding Z by minimizing the mean squared error to the test reward function, which can be solved in closed form. This gives us a Z conditioned near optimal policy without additional learning or planning. This pre trained decision making model is Behavioral Foundation Model or BFM. So now we have a way of learning a lot of different skills in producing zero shot policies. But we still need to provide a reward function at test time to find the task embedding Z. How can we make it more intuitive for humans to interact with agents? For example, a human specifying the task to do a lunge to the robot here. Can we use language to understand intent and determine reward function? We take inspiration from how humans know what needs to be done when they think about a task instruction. If a human is told sprint like a quadruped, they are instantly able to understand what it means because they have seen so many quadrupeds running throughout their lives. We have similar priors in foundation models. Video generation models are trained on large scale internet data and can generate anything we specify via text instructions. However, these imaginations are untenable as they are. We do not have the actions between frames that we can simply imitate. The consecutive frames might be inconsistent with the dynamics of the current agent, and moreover, the generated imaginations can be noisy. To resolve the issue of noisy frames or cross-domain transfer, we find the nearest frame in the offline pre-training dataset of our agent using semantic similarity matching. By finding the nearest observations, we obtain the corresponding proprioceptive states. Now, we have the behavior we want to mimic, but it is still dynamically inconsistent and lacks actions. We propose state only visitation distribution matching as a solution to those issues. We intend to find a policy in the skill space of the agent that matches the distribution of states in our projected imagination. We show that there is an approximate closed form solution to this imitation problem simply by averaging the features of expert states. Thus, the process of finding the zero shot policy does not require any further learning. Overall, our approach comes together in three parts. We produce an imagination from a language instruction using foundation models. We next project these imaginations in the agent's domain. Finally, we can imitate these projected imaginations by finding a task embedding with BFMs. Here are some test results from DMC. The pre-training has been performed using data collected with R&D exploration policy, and then we test it with a collection of prompts to analyze its behavior. We can see that we can generate meaningful behaviors without any test time training or supervision. This is language to behavior policy inference. But can we do this across domains? Our projection step is domain invariant as a result of semantic similarity matching and works across domains. We can simply replace the imaginations with real videos from YouTube, enabling zero-shot cross-embodied demonstration to policy. We did extensive quantitative evaluation of our method and observed that it produces behaviors that are more realistic as voted by multimodal LLM as judge. RL0 is preferred 83.2% over other methods, and it's also worth noting that all the methods that we are comparing with here require test time training. Please visit our poster on Friday to find out more.